Hi. Today I'd like to talk about proof by induction. In geometry class, you probably learned proof by deduction. And in proof by deduction, what you did was you were given some statements, and then from those statements you needed to show that this final statement was true. So, for instance, if you had triangle ABC here, and I've got angle D out here, you might be given triangle ABC, and you wanted to show that angle A plus angle B is equal to angle D. And how you went about doing that was by saying, well, angle A plus angle B plus angle C is equal to 180. That's the definition of a triangle and the sum of the angles there. You could then say angle A plus angle B equals 180 minus angle C. That's just subtraction. Then you could say that 180 minus angle C over here, 180 minus angle C is equal to angle D. And now that I have 180 minus angle C equals this, and 180 minus angle C equals that, I can then set the two things equal, and I've shown that it's true. And that's a proof by deduction. But today, we're looking at proof by induction. So how does that proof work? Well, essentially, you want to show that a statement is true for all cases. You need to show that it's true for the very first case. Then you want to assume it's true for all but the last case. And then you need to prove that if it's true for all of those cases, it's also true for the last case. So as an example, I want to show that the sum from I equals 1 up to k of I squared, which remember is equal to 1 plus 4 plus 9 plus 16 plus all the way up to k squared, that equals k times k plus 1 times 2k plus 1 all over 6. I want to show that that's true for all k. Show this is true for all k greater than or equal to 1. Okay, well, so first, show it's true for k equal 1. All right, well, when k equals 1, I have 1 times 1 plus 1 times 2 times 1 plus 1, all divided by 6. 1 plus 1 is 2. 2 times 1 is 2, plus 1 is 3. 2 times 3 is 6. 1 times 6 is 6. 6 divided by 6, this does equal 1. So it checks for the base case. Okay, now we assume it's true for n, and we have to show it's true for n plus 1. All right, so since it's true for n, we know that the sum from I equals 1 up to n of I squared is equal to n times n plus 1 times 2n plus 1, all divided by 6. That's true by assumption. Then I need to look at the sum I equals 1 to n plus 1 of I squared. That's equal to the sum I equals 1 to n of I squared plus n plus 1 squared. I add the first n terms, which is this, and then I add the n plus 1 term, which is this n plus 1 squared. So since I know this is true by assumption, I can replace that in here. So I know that the sum up to n plus 1 of I squared is equal to n times n plus 1 times 2n plus 1 all over 6 plus n plus 1 squared. And now what I need to do is show that this is also, this part, is equal to n plus 1 times n plus 1 plus 1 times 2n. I need a little more room here. Can I move this over? Yes, I can. There we go. It's nice with the smart board here. That this is equal to n plus, and let's move this down a little bit so it's not all bunched up. So that this is equal to, here, now, we'll just move this all the way down there. There we go. That this is equal to, this first part here was equal to n plus 1 times n plus 1 plus 1 times 2 times n plus 1 plus 1 all over 6. I'm just plugging in n plus 1 in our original formula way back up here. So now I just need to do a little algebra to show that this green thing, which I know is true, and I've already got this part, and I know this, equals this thing. So the question is, are these things equal? Well, first thing I'm going to do is multiply this last term times 6 over 6. And now I have a common denominator, and I only need to worry about the numerators here. So let's see if the two numerators are equal. So this green numerator, I have 2n squared plus n plus another 2n, so that gives me 3n plus 1. That whole thing times n, so that's 2n cubed plus 3n squared plus n plus 6 times, and now I need to FOIL that out, n squared plus 2n plus 1. And so I get, here I've got 2n cubed plus 3n squared plus n plus 6n squared plus 12n plus 6. Now let's combine like terms here, and we have 2n cubed plus 9n squared plus 13n plus 6. So that's the green side. Now we've got to do the red side, and we're only worrying about the numerator here. So first off, I have n plus 1 times n plus 2 times 2n plus 3. And that's over 6, but we're only worrying about the numerator here. So let's take that. I just want to not have to rewrite everything. So we just need to expand out this numerator. So we have n times n gives me n squared plus 2n plus another n, so that's plus 3n plus 2 times 2n plus 3. I'm running out of room on my smartboard here. Oh my gosh. Never happens. There we go. So now we need to multiply this part out and see if it equals that. So we have 2n times n squared gives me 2n cubed. I should do this in red. 2n cubed. I have 2n times 3n gives me 6n squared. I have 2n times 2 gives me plus 4n. I have 3 times n squared gives me 3n squared. I have 3 times 3n, which gives me 9n. And I have 3 times 2, which gives me 6. And when I add those together, I get 2n cubed plus 9n squared plus 13n plus 6. This is equal to this, and I'm done. I have proven by induction that for all k, I equals 1 up to k, the sum of I squareds is equal to that. And that is an example of proof by induction.